So welcome to today's Tech Hour. The motivation for this was that the Tech Hour has been running for about a year, and I thought it was time that I actually got involved in doing something besides running the Tech Hour and dealing with accessibility. And I came to the view after surveying things for a bit and learning a bit about myself that an accessible LaTeX math checker would be the thing to go for. And partly that's personal because of the interests I have and because I'm retired, so I sort of don't have the benefits and the burdens of a workplace. And what I'm going to do is briefly explain what I envisage this sort of thing being. And then I'll try and open the discussion up because I know there are people who've got real interest here. So let's get going. I think one of the things about myself is that from about the mid-90s, I've wanted tech to be much, much closer to XML. And in modern terms, that means that every tech document should have an abstract syntax tree. And what that means is that what you see is a representation of a structured object that you can navigate. So you can navigate up and down and across and so forth. So every web page has an abstract syntax tree, but somehow tech documents don't. And then once you've got an abstract syntax tree, you can do lots and lots of transformations on it. It's very useful. So I think part of the motivation for this is garbage in, garbage out. That's an old statement in computing, and it roughly means it doesn't matter how good your program is, if the data that comes in is rubbish, then you can't get any value coming out of it. And the machine learning software might or might not provide a counterexample to that principle. I'm not going to go there. So the idea of a syntax check, of an accessibility checker, is that you're writing a document and you want to know whether it's garbage or not. And I see that as being quite a useful unifying feature for all the various tools that exist. So, and some that don't. So there's all manner of ways of getting from LaTeX source to HTML. There's Tech for HT, there's Plastic, there's LaTeX ML, there's Pretext, which is slightly different because it starts with XML and produces LaTeX, but we can still apply tools to it. There's LWARP, and there's the LaTeX 3 tagging. Now, all of those tools, with the exception of Pretext, which is an XML input, you'd expect the author to be creating something that is not garbage, something that is acceptable input. And you'd like that to have a definition that's independent of the tool. You don't want the tool to say, oh, let's move to version 2 and all my documents are broken. There was nothing wrong with them before. So you want a sort of definition of what's acceptable input. So that's the sort of one of the functions I see for that. And another function I see for this is that most users are not concerned with which of the many tools they use. What they're concerned with is what comes in and what comes out. I mean, most people don't particularly care whether it's a diesel car or well, it's for taxi. They want to get from A to B. They want to be somewhere else. It's not that they care about the vehicle that's carrying them. Often you want to send a message and it doesn't particularly matter whether it's text or phone or email. You just use whatever it is, but it's the message you want to send. So I'm sort of seeing that that seems to be a niche that doesn't exist. Sorry, a niche that is unfilled. That there's not a sort of convenient tool for syntax, for checking the accessibility of a LaTeX document. And there are for web pages, you can send your web page to an accessibility checker and you get a result. And there's also accessibility checkers for PDF now. You send it in and you get a result. Here, I want to be able to send it in and you get some sort of results. And because the whole thing is poorly defined and because there are multiple tools that could be used to turn the LaTeX into HTML or whatever your accessible format is, there's a lot of ambiguity. But I see that as an argument for having the tool rather than an argument for not having the tool. Because once you set up the tool, you start to measure and reduce the ambiguity. So that's a sort of, in the large picture, I'm sort of pure mathematicians are often interested in large pictures. In the small picture, I see it as a relatively small project in the sense that you can start getting useful results quite quickly. So one of the useful results is you can actually say, you could once you have the abstract syntax tree, you could say, these are the mathematical commands used in this document. Are they appropriate for your students? And this is the level of, so to speak, mathematical complexity of the document. Is that appropriate for your students? So one could, at least in principle, produce a readability guide based upon the abstract syntax tree that you get from the LaTeX document. And the final thing I see is that having, at least for a subset of LaTeX, a transformation that gives you an abstract syntax tree, I think is really, really valuable, because it's a bit like I think it's called the end-to-end problem. So if you've got if three people in town have a telephone, then you only need 3 lines between them and everybody can talk to everybody. If you've got 50 people, then you need 25 times 49 lines, which is an enormous number of lines. And by the time you get to the size of New York, it's astronomical. And so the way you solve it is you have a hub and every phone connects to the hub. And an abstract syntax tree means that anybody that wants to process a LaTeX document doesn't have to parse it themselves. They say, it's already been parsed, I will deal with the abstract syntax tree. And that guarantees that everybody reads it in the same way. And in computing, there's software such as libxml that provides tools for turning an XML document into an abstract syntax tree. And for what it's worth, there are libraries for dealing with zip files. So if you want to deal with zip files, you don't have to write a zip file dealer for your application. You use a library that opens the zip file and turns it into something useful. So it's a sort of standard transformation, just as a screwdriver is a way of turning a screw. So I see a core part of a syntax of a LaTeX accessibility checker being a conversion to an abstract syntax tree. So I think I've finished my introduction now, and open to contributions, and maybe those with a special interest in accessibility first.